Good morning, Biology 102. Today we are talking about conservation biology solutions to some of the ways that humans threaten biodiversity. That was our last lecture. So today we're talking about some of the solutions and some of the ways that scientists are thinking about mitigating some of these problems that humans are creating. So first off, conservation biology is a goal-oriented science that seeks to kind of counter the loss of biodiversity. Remember, biodiversity is the loss of ecosystems, variety and types of ecosystems, variety and types of species across sort of Earth's globe, and then also genetic variation within those species to kind of sort of keep that variation that presents a healthy population for planet Earth. Conservation biology seeks oftentimes solutions not only for that biodiversity at a genetic level, a species level, an ecosystem level, but it also seeks these solutions long term. So we're looking for not only solutions for now, but also something that will last into the future. I have just a few examples of conservation solutions that I want to walk through, 6 of them. There are more than this, but this gives you a smattering of ideas. So I want to talk about conservation programs to protect different areas, especially biodiverse areas, habitat fragmentation solutions, green urban development, government regulations, captive breeding and reintroduction programs, and lastly, sustainable development. So these are some of the ways that we are trying to protect these different habitats and ecosystems from human threats, right? So first off, biodiversity hotspots. So what is a hotspot? On my map over here in purple, you can see the hotspots on planet Earth. And hotspots are small areas with exceptionally high numbers and varieties of different species, often endemic species. Endemic species are species that only occur in one location on planet Earth. And so one of the solutions in conservation biology is to sort of set aside or protect those areas with these high biodiversities, these high number of endemic species that are existing. This can be done like in 1872, we set aside Yellowstone as one of the first national parks in the world, and we set that park aside so that humans would have a space to go and see geologic features, but by setting it aside, we also protected a lot of the living things in the space as well. From national parks, we now protect green spaces in various parks, city, all the way up to national parks that we see. So cities, state parks, regional parks, and then all the way to sort of national parks. There are also other theories on how to protect areas. Costa Rica and some other places are actually doing something called a zoned reserve, where they have different zones around their country where you can do various activities, like maybe in one zone only other living things, humans aren't allowed, only other living things are given that space for habitat, shelter, food collection, migrations, mating, etc. And then there will be other zones where maybe humans are allowed to come in intermittently, but you cannot live there, so there's no urban housing. And then there's areas that allow for like housing and transport of humans. And so they'll have different reserves, and each reserve area will have different rules or laws about like how humans may sort of utilize that particular space. So all of these ideas kind of help to protect and provide these natural green spaces that are left behind, not only now, but for future generations as well. Now, when we think about splitting up and isolating populations, habitat fragmentation is a problem that we see all over. When we build roads or dams, these kinds of things will separate or fragment different groups of populations so that they cannot migrate or mate, find food, shelter, etc. And so this can be very problematic. So some of the solutions are to encourage natural edges around like fields and things like this. This was done in Europe. And these natural edges allow organisms to have habitat in spaces. Instead of farming edge to edge, then we leave a little bit of a natural border around different areas, and this can create some spaces for things like foxes and rabbits and native species to sort of exist. Habitat or movement corridors like this one shown in the picture here provide ways for different organisms to move over these habitat fragmenters. Fish ladders do this as well upstream, allowing fish to go up and down streams around sort of dams and things like that. And zoned reserves also provide oftentimes migratory sort of places or paths, so that animals and different things can like sort of move from one zone to the next. So all of these things are trying to find solutions to link back up these different isolated groups of living things. The third thing I want to mention is green urban development. In green urban planning, we are always like thinking about the future. So we're thinking about sustainability, not only trying to leave green spaces and improve connections of humans to green spaces today, but also leaving them behind for future generations. And a lot of the urban development, there's a couple of different principles that people are talking about. One is clustering in kind of loops or circles where humans are clustered next to everything that they need to live. And then leaving spaces within those loops, green spaces for other living things to live as well. And so one idea is not only to like sort of disregard sprawl or moving cities outward. One idea is to build up and have cities with green spaces go upright and then connect humans to their jobs and schools and offices and their homes, all within those like kind of loops, everything that they need. Another thing that is like sort of at the core of this, not only sustainability, a look to the future, kind of mitigating urban sprawl or moving outwards. Another thing that humans are looking at in these urban plans are to leave these spaces for different organisms besides humans and really learn to live with other living things. So rather than pushing living things away from these sort of urban spaces, allow for bats and birds and things to have nesting sites and whatnot within like sort of these urban development plans. This leaves habitat and leaves spaces and food for those different species, and then humans are kind of living around. There are lots of talks about how to do this, and I'm sure you'll hear more about it in the future. The fourth thing that I want to mention is government regulation is important. Our own government has various kinds of regulation, like the Endangered Species Act of 1973, that protects species in danger of extinction throughout all or a significant portion of their range. It also lists threatened species and provides some protection for those particular species as well. This occurred in 1973 and 1975. CITES, the Convention in the International Trade of Endangered Species, is like the international counterpart. It does something similar as the Endangered Species Act, but in a global or an international sort of space, protects species from being illegally traded and transported across like sort of international boundaries. And things like the Clean Air Act, this started in the early 1960s with some kind of predecessor acts moving forward, and it's been amended several times throughout like sort of the years, but this protects our air from having pollutants that like sort of are distributed into the space and can provide like some government regulations, some penalties for companies, things like that are releasing these particular gases. I think at the heart of government regulation is not only identifying laws that help us protect other living things around our development and around our like sort of countries, but also provides funding for researchers, for wildlife officials to actually run these programs at the ground level. And so the funding and sort of diversion of funds into these sort of programs, conservation programs, is also really important. Number 5, captive breeding programs and reintroduction programs. So I show a koala because last year in 2019, there was huge fires and people were collecting koalas and things like that in order to try to save them from these huge fires that were hitting like sort of and destroying portions of their habitat in Australia. And so those animals were brought into captivity to rehabilitate them in hopes of releasing them. So captive breeding is where we breed endangered or threatened species or species in danger, like these animals in the fire, in hopes of like sort of rehabilitating them and then re-releasing them. That's called reintroduction, where we raise and release those particular organisms back out into the wild. The hopes of these programs is to stabilize numbers. And there have been some successes, some cases where we've released different fish species, grown them up as fry, and then released them back into aquatic systems so that we have those native species in our freshwater systems. So there's been some successes. There's also been some that are still struggling, and the costs of these programs, you can imagine, are quite high. But there is this possibility of like kind of rescuing and saving and stabilizing some of these populations that are struggling for a variety of reasons in the wild. The last sort of conservation biology solution I want to talk about is sustainable development. And you've probably heard about this in your towns or on campus. Sustainable development is using natural spaces so humans really get what we need from a particular area, but also don't damage a system for future generations. It's really at its heart, it's got this idea of replacing what we take, thinking consciously about what we're taking, not over exploiting an area, and then replacing what we're taking so that future generations can also have those particular resources. Plans for sustainable development are also often long-term, with goals for both humans and also the living things in a particular area, moving not only looking at now, but moving into like kind of the future as well. There are lots of sustainable energy plans in the government and in different communities, talking about how to move from these kind of non-renewable energy resources that cause some pollution problems to some sort of renewable energy systems. And so getting campuses or communities to move towards those kinds of things is really important. There's also things in developing area and just taking resources like logging, right? So forestry, there's lots of sustainable logging principles where we take part of a forest, replant what we've taken and leave some of it so that you have this forest that is sustainable over long periods of time. All of these solutions, I hope that you're thinking about what you can do, and I challenge you to think about just starting really small and what is something that I can do that mitigates some of these impacts that humans have on their environment. So I will see you next time.